Hi everyone, this is the 5th section of Chapter 1 and it is titled Angle Relationships. It's focused on classifying different types of angles and what are some of the special relationships or names of pairs of angles that have a relationship. There's also a little bit in here on perpendicular lines formed from right angles. Okay, so the first term is adjacent angles. Adjacent angles are side-by-side angles, you could say. They have a common side between them. Over here in the diagram you can see that angles 1 and 2 here are adjacent, they are side-by-side, and they have a common side here. You can also say they do not overlap, and they have no common interior points. So you can't have one angle inside of another, for instance, and call them adjacent. So they're really side by side, no common interior points inside the angles. And here 1 and 2 are also adjacent. They share a common side and they do not overlap. A linear pair, well, pair means two, and linear, I guess you could say, is form a line. So you can kind of get from the name that a linear pair is two angles that form a line. And you can see very clearly in the diagram they are also adjacent. So 1 and 2 are adjacent and they form a line. So two adjacent angles that form a straight line. And I think you can imagine if they form a straight line, then those two angles must sum to 180 degrees because that's the angle of a straight line. So why don't we write that? Angle 1 plus angle 2 here has to equal, the sum has to equal 180 degrees, a straight angle. And that leads into the next term, which are supplementary angles. Supplementary angles are two angles that sum, whose measures sum to 180 degrees. So we could say two angles. Notice I didn't say adjacent angles. Two angles whose measures sum to 180 degrees. So the concept between supplementary angles and linear pair are very related. A linear pair are supplementary angles. Supplementary angles may not necessarily be a linear pair. So if you think about that in terms of like a Venn diagram, you can say supplementary angles would be on the outside here. I'm just going to abbreviate supplementary angles, and inside that subset, if you will, is a linear pair. You could think about it kind of that way. And the reason why I say that is because here 3 and 4 angles, 3 and 4 certainly are a linear pair. They are also supplementary angles. There are two angles whose sum is 180 degrees. However, angles P and Q, we could also say that those angles are supplementary because their sum is 180 degrees. However, they are not a linear pair. So I'm going to just write that over here. 3 and 4 sum to 180. They are both supplementary and a linear pair. Angles P and Q also sum to 180 degrees, so therefore they are supplementary, not a linear pair because they are not side by side or adjacent. Complementary angles, on the other hand, are two angles whose sum is 90 degrees. So two angles, and again I did not say adjacent. So over here in the diagram, you can have two adjacent angles, such as 1 and 2, that are complementary. And we know they're complementary because they're adjacent and they are making up a 90-degree right angle. But you can just as easily have two non-adjacent angles, such as A and B, whose sum is also 90 degrees. So let's write that out. Does not need to be adjacent. Okay. Vertical angles. Vertical angles can be a little tough sometimes to grasp because in English, vertical means up and down. That's in English. So if we said horizontal, we would mean left to right. Vertical is the opposite, up and down. And that's kind of an English translation. The problem is, in geometry, vertical does not mean up and down. So vertical in geometry is talking about angles that are opposite each other. They are, in other words, not adjacent angles. They're opposite angles that are formed by intersecting lines. So opposite angles formed by intersecting lines. And if you look at the diagram over to the right, you can see that there's two pairs here. That's my dog crying. Two pairs of vertical angles formed by two lines intersecting. And here, angles 3 and 4 are a pair, and the relationship between vertical angles is that they are always congruent. So angles 3 and 4 are congruent, and they are a pair of vertical angles. Also, 1 and 2 are vertical angles, and they are congruent. So I'm going to show them as congruent. So angles 1 and angles 2. So both of these are considered vertical angle pairs. Okay, perpendicular. Perpendicular is an adjective that describes lines, segments, rays. It could describe any one of those, and it's really talking about their relationship being formed by a 90-degree angle. So some lines are intersecting, or segments, or rays, or a combination of the two. As long as you have that 90-degree angle, we would describe those lines, segments, and rays relationship to be perpendicular. So in this particular diagram, we have two intersecting lines. We have line AD, and we have line BC, and we would say that they are perpendicular to each other. Their relationship to each other is perpendicular. This symbol here is a symbol for perpendicular. All right. Interpreting diagrams. Okay, some things can be assumed and some things cannot be assumed when looking at a diagram. And all year long we are going to be interpreting diagrams, so we need to understand what we can assume and what we cannot. In looking at this somewhat complex diagram here, we've got some lines and rays coming out here from point H. Let's talk about what first can be assumed when we look at that diagram. The first thing that we can definitely say is that all points are coplanar. They are all on the same flat surface. They're all on the same plane. So we can assume that. The next thing we can assume when looking at this diagram is that points G, H, and J are collinear. So we can say points G, H, and J are collinear. We can also say, I'm going to separate these things here, we can also say that these rays here are all intersecting at point H. So let's say HG, HM, HL, HK, and HJ. They're all intersecting at point H. Since this is a line here, GJ is a line going infinitely in both directions, and we have a segment in between G and J, we can assume, looking at this diagram, that H is between points G and J. And that lends itself to the segment addition postulate, such that GH plus HJ is going to equal the length of GJ, and these are all segments. Okay, let's talk about angles now. And in order to make that easier, I'm going to label the angles with numbers. 1, 2, 3, and 4. Whoops, that's 4. Okay, we can certainly say that angles 1 and angle 2 are adjacent. Likewise, we could say 2 and 3 are adjacent, or 3 and 4 are adjacent. I'm not going to write all of that down, but you can certainly write that in your notes if you would like. We can say that all of these angles here, 1, 2, 3, and 4, will sum to 180, and I am going to write that down. So we can say, since they are forming a line, that the sum of all 4 are going to be 180 degrees. And we can also say, because of that then, we can look at larger angles, and in this case I'm going to have to use the letters. I can say any combination here that are not overlapping are supplementary. I'm just going to choose maybe 1 and 2. I'm going to say angle GHL and angle JHL are supplementary. And since they also form a line and are side by side, non-overlapping, you could just as easily say that they are also a linear pair. Now there are many things that cannot be assumed in looking at this diagram. By the way, as I'm looking at my writing here, I can see I forgot a C in here. Okay, so what cannot be assumed? Well, we cannot assume, for instance, that HJ and HL are perpendicular. This angle here, I don't know if it looks 90 degrees to you or not. If it did, to me it looks acute, but even if it were really close to your eyes, but not marked as a 90-degree angle, you cannot assume that. So HJ cannot be assumed to be perpendicular to HL. If the angle is not marked as right, then you can assume it. In terms of angle measure, we cannot assume. It certainly does look like angle 1 is congruent to angle 4, but they are not vertical angles. If you notice, they're not opposite angles. It may appear that way, but they're not. In order to be opposite angles, you need 2 lines intersecting. This line here, HM, would have to continue on for angle 1 to be vertical with something over here. So you can't assume that angle 1 and angle 4 are congruent cannot be assumed. Likewise, angle 2 and angle 3 appear to be congruent, but we cannot assume that because they're not marked that way. And finally, talking about segments, we cannot assume any segments are congruent here unless they're marked. So, for example, segment GH cannot be assumed to be congruent to HJ, or HM cannot be assumed to be congruent to HK, and any other segments that are not marked to be congruent. There are many other things here that we cannot assume, but hopefully you're getting the idea that unless the drawing or diagram has something marked with a measure or with congruency, you cannot assume it. Let's start to practice a little bit with some examples. Name 2 adjacent angles whose sum is less than 90. As we discussed, adjacent angles are side by side. They do not overlap, and those angles have a common side to them. There are only 2 answers to this question, and if you look over here on the angles, 55 plus 30 is 85. So those 2 angles are side by side. They are adjacent and they are less than 90, as well as these 2, which happen to be their verticals. So we can write that answer as follows: angle BAC and angle DAC. And you can write their vertical pairs as well, would be another answer. NAF and angle FAE. Number 2, name 2 acute vertical angles. There are 2 answers to this as well, and they are related to the answers above. So we can see that these 2 are vertical and they are congruent, and these 2 are vertical and congruent, and also meet the requirement to be acute vertical angles, which means less than 90 degrees. So we're looking for less than 90 degrees. So you could have answered angle BAC and FAE, as well as CAD and angle NAF. All of these are vertical and less than 90, which means acute. Number 3, find the measure of 2 supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other angle. And the best thing to do in this case is to draw 2 supplementary angles. The easiest thing to do is draw a linear pair. We don't know here what this other angle is, so we're going to assign a variable. This other angle is x. I have no idea what it is. And its supplementary angle is 6 less than 5 times that angle. So 5 times that angle is 5x, and 6 less than that is 5x minus 6. I have no idea if 5x minus 6 is the obtuse angle or if x is the obtuse angle, but this is a sketch. It's a starting point, and it helps you write some kind of equation that models the problem. Okay, so we know that these 2 angles are supplementary, so we could say that 5x minus 6 plus x sums to 180. And I'm just going to combine like terms. 5x plus x is 6x, minus 6 is 180. And I'm going to try to isolate this unknown. So I'm going to first, well, we might as well remind ourselves of this. We basically use the order of operations in reverse to isolate that unknown. So the first thing we're going to do is undo that subtraction, and the next thing we're going to undo is that multiplication. So we undo subtraction with addition. I'm just going to rewrite this over here. So we're going to add 6 to both sides of that equal sign, and of course opposites reduce to 0. And then I'm going to rewrite this over here. I'm going to undo that multiplication with division. And this is supposed to be a degree here, but it's confusing things, so I'm going to erase that. Anything divided by itself reduces to 1, and we end up with 31 for x. But the question was to find both angles, so one angle here, x is 31 degrees. I happen to just by accident have chosen correctly that that's the acute angle. Now 5 times 31 is 155 minus 6, and if we look at 155 minus 6, we get 149 degrees. So 149 plus 31 should sum to 180. And that does, so that's a good way to check your answer, that both angles are indeed supplementary. Example number 4. Find the measure of two complementary angles if one angle measures 5 degrees more than twice the measure of the other. I like to think of straight S as 180, supplementary straight, and complementary corner as 90. So that's a good memory jogger for us. So we've got 90 degrees summing. Okay, so let's draw some sketch. So we've got an unknown angle, and the other angle is 5 degrees more than twice the measure. So twice the measure of x is 2x, and 5 more than that is 2x plus 5. So we can write an equation here, 2x plus 5 plus x equals 90, because they are complementary. 2x plus x is 3x plus 5 equals 90. Now we're going to undo our operations here. We're going to subtract 5 from both sides. 3x equals 85. And we're going to divide both sides by 3. And we get x equals 2, and our remainder here is 2, and 3 goes into 25 8 times, and our remainder there would be 1/3. Try to resist the notion of turning this 1/3 into a decimal, because as you know, 1/3 is a repeating decimal. It's just cleaner to leave it as a fraction, I think. So then one of these angles here, x is 28 1/3 degrees. So if we substitute in 28 1/3 over here into the other angle, this expression here, 2 times 28 1/3, I'm going to do that over here, I think. I'll do that right here. So 2 times 28 1/3 plus 5, that would be 56 2/3 plus 5, and 56 2/3 plus 5 would be 61 2/3. I'll circle that. So over here we can just check our answer, and this is another reason why I think it's just better to leave the angles with the fractions. So 61 plus 28 would be 89, and 2/3 plus 1/3 would be 3/3, or 1/2. So that completely checks out to sum to 90 degrees. Example number 5, last example. Find x and y so that the line KO and the line HM are perpendicular. So let's look at the diagram. KO is here, Actually, why don't we just go ahead and highlight it in red. And HM is here. So we want these two lines to be perpendicular. That would suggest that this angle here would have to be right. So this expression, well, we might as well use the letters MJO, angle MJO. We want to equal to 90 degrees, its measure. So let's substitute in 3y plus 6 equals 90. And subtract 6 from both sides. And we have 3y equals 84. Divide both sides by 3. And we get y equals 2. The remainder of 2, 28. So far we've found that y equals 28. Now, if you can see in the diagram, MJO is vertical to KJH. And hopefully you can see that. So this angle here would also be right. They are vertical angles, and of course perpendicular lines form for right congruent angles. So that would mean that KJH is also 90 degrees. So now I'm going to substitute. I have two angles, two non-overlapping angles that make up that angle, so I can just add them. So I'm going to substitute 3x plus 6 plus 9x equals 90. And I'm going to combine like terms. 12x plus 6 equals 90. And subtract 6 from both sides. And we have 12x equals 84 again. Whoops. And I'm going to divide both sides by 12. And x equals 7. So we have both of our variables, our unknowns, solved for. Thanks for listening. Take care.